Hi, my name's Alan. I'm Principal Technologist here at Macrometa. So today I have a really exciting demo to share with you, which is our first-person shooter demo. So of course, it's a gaming demo. It's built on a Unity engine, but the part here is that we actually replaced all of the back office, all of the netcode transport with Macrometa GDN. And so all that data processing is now being handled by our platform, which enables a variety of really compelling and great use cases that I'm going to share with you today. Okay, so here we are at the main screen. As you can see in the top right hand corner, I have the liveops dashboard and I have the introduction screen for the first person shooter game. So what I'm going to do is I'm going to set up my lobby. So if I come over here to a new game, I've already got my name in here. It's Alan, as we know, and I'm going to create a lobby. My lobby. Okay, so let's create that lobby. Okay, so you can see I'm here in London. Unfortunately, I have no friends with me today to play, but what I'm going to do is add myself here and I'm going to take some practice. So what we've done is we've also implemented some bots in here that are also basically connecting to this game in the same way that I am doing. So I'm going to add them in here. So I'm going to add 3 in. Let's see. And then what we'll do is we'll start the game. Okay, and I will see you in a minute. Okay, so we're in the game. You can see the liveops dashboard is running. Looks like I'm playing a robot this time, but let's go around and see if we can find some bots to shoot. Okay, so oops, somebody just took a pot shot there. Let's see. Anyway, so this is the first person shooter game. As I say, it's built on a Unity engine and all of the back office is replaced with Macrometa GDN. So we are replacing all of that netcode transport. So all of the data of the game is flowing through Macrometa GDN. Okay, now there's another one. So the great thing with this is now I have full visibility of everything that is going on in the game. So as you can see on our dashboard, we've cherry-picked some, specific data that we want to highlight. So, for multiplayer games, latency is really important. So we highlight that on the dashboard in real time, showing what is going on. And you can use that information then to sort of, advise, gamers if they're lagging or not, or something like that. Or we can, because we have access to that data, we can actually look at creating a level playing field environment. So putting gamers into the right sort of matchmaking lobby, rather, during the matchmaking process, where they're able to then, play a game with people of a similar latency and a good latency. We also take a look at the frames per second, because frames per second is really important for a smooth gameplay experience. And then we have the kind of actual gamer data itself, which is their current health in real time, the shots fired, their kill to death ratios. In this case, we also have grenades that are being launched, and we also have a little map that actually tracks in real time the locations and where people are whilst they're playing the game. Now this is really, really cool for game studios, because now what you can do is track all your games wherever they are in the world, and the gamers who are playing them, how long they're spending in the game, whether or not they're quitting early, whether or not the game's booted them out or something. So you get a real sense for whether or not the health of the game, but also the gamer's journey and actually how they are experiencing that game. And that gives you invaluable insights to basically optimize your game, and you're getting these results in real time rather than waiting for them to be processed days after the fact and in a big batch process. You're actually getting those insights straight away. Gotcha. Right, so that's one part of it. So now the studios have access to all that data. What if you were actually doing an esports event? This is where data and gamer statistics in general becomes really important. Because gaming events like an esports event, what you're looking at is gamers that are far more competitive, and there's usually advertising involved, there's usually cash prizes, things like that. And if you were a commentator on this, normally what you'd have to do is look at people's gameplay and look at all the different screens and try to work out what's actually going on. But what if you actually had a dashboard that actually showed you a summary of everything that's happening in the game? Now what you have is an ability to add really rich commentary data, really rich data to your commentary, providing a much better, more detailed explanation of what's going on in the game, right? Sorry, I'm looking for another bot to shoot. Okay, so there's an awful lot that can be achieved with once you have access to the actual data inside the game. And as you can see, this is running incredibly smooth. It's buttery smooth on Macrometa. I'm getting about 60 frames per second right now on there, and and it's a great experience. Okay, great. So what I'm going to do is I'm going to turn this off now, and you've had enough of me running around trying to shoot bots. What we'll do is we'll actually get into a bit more detail on the gaming industry in general, and what kind of expectations there are going forward, and what are the things that the gaming studios would like to achieve with the games and the gaming platforms that support them. Okay, great. I'll see you in a minute. Hi. Okay, so we're on to this part of the video where we talk a little bit about the challenges that the gaming industry faces. Now, as I said earlier in the video where you watched me chasing bots around, we built this game using Unity, but we replaced all the netcode transport using Macrometa GDN. And we did this for the purpose of showing how you can delight your gamers. But there are real challenges when building a game. It's like, how do you keep your gamers delighted and engaged? A lot of the time, the data that you're trying to analyze is usually historical by the time you get it, and you can no longer make a real-time adjustment to the actual gaming experience. So getting access to that data and getting insight into the gamer journey and experience is really challenging, and it is incredibly valuable to be able to do that. But then also, how do you manage that gamer experience at a global scale? It's not an easy feat to do. There's a lot of moving parts. A lot of the technologies people and game studios employ is often centralized. It's not close to where the gamers actually are. So the actual performance takes a hit on actually how you gain those insights. But then what if you're thinking about the actual game mechanics themselves? So things like the physics engine, whether or not somebody is having somebody is cheating in the game. Perhaps somebody is actually, like I showed earlier when I was playing the game, there is a little map in the corner, if you remember, that showed where all the gamers were moving. With our implementation, you're able to track where gamers are in real time. So if somebody's having an unfair time where they're getting spawn killed all the time, you could actually adjust the mechanics in real time to actually move the spawn point to somewhere else in the game. Or you could spot somebody who's actually got a lag switch engaged, or so there's something going on with the packets that are being delivered. You can detect that in real time. And what if you want to manage that in-game data at scale as well? Say you're doing a role-playing game with a very detailed in-game economy. How do you handle that across the world so that so you don't have lots of smaller economies going on? Maybe you just have one in-game economy, and then you have different views of that economy from the different regions that people are playing in. How do you actually go about doing that? And what if you actually want to add persistence to your game? Say, some games talk about having a persistent universe or even a metaverse. Being able to persist data is a real challenge. How do you manage that? And how do you let gamers join the game wherever they are in the world and get access to the data that they need to actually play the game themselves? Okay, it's a real challenge. And of course, then you've got something that's a very hot topic right now, which is how do you provide cross-play and cross-save for gamers? These days, gamers actually will play across many different devices, and they'll want to play the same game across those. So if they're at home, perhaps they're using in a studio somewhere. Perhaps they're using their PC rig. Maybe if they play in the living room with the family, they've got a console, or maybe they're doing some cloud gaming where they're streaming it. Being able to manage the state of a game and save it, and then share that state between these different game delivery mechanisms and gaming devices is a real challenge. Often the kind of companies that provide this technology could actually be your competitors. Perhaps you don't want to actually work with a gaming studio that's your competitor. Maybe you need an independent company or build your own approach to actually solve these challenges. And then, of course, crossplay, where you want to be able to develop your game to run on any kind of device, whether it be a handheld, a mobile device, or a high-end PC, and you want to actually enable gamers from these different devices and these different communities to come together in one community where they can actually play together. Okay, how do you actually go about implementing that? So Macrometa GDN is a converged technology stack. It's globally distributed, it's low latency with high velocity, stateful data computing services. It's made up of three main parts. The first part is our global data mesh. This is basically the part that lets you connect any source of data to any sink of data. It lets you process data at rest and process data in flight. You could do all kinds of cool things with this. You can do search, multiple views. You have a multi-model database that lets you deal with key value, documents. We have wireline protocol support for all kinds of data sources and sinks. We even have graph technology built in, so you can actually do graph traversals and do all kinds of cool recommendations and things. Well, then the second part is our edge compute. This is where you put APIs on any of this on the data in seconds. You can also write your application logic, which is what we've done in this demo, within the stream workers. You can bring your own containers, so your own game servers, like we have done here with the Unity engine, which will actually run on and be orchestrated by our compute. And then finally, we have the data protection part that lets you carve up the GDN into any way you can imagine to provide different slices, if you will. So for global views, local views, or hyperlocal views of the data that is going on. You can also handle all your security here and all kinds of different views of the data that you would like. So now that we've covered a bit about what Macrometa GDN has under the hood, let's talk about how we actually used it to implement the netcode transport and support the multiplayer game that we have on Unity. So we have the Unity engine here, which is in a classical server client architecture, and this blue box is representing Macrometa GDN. So as you maybe remembered in the first part of the video, we talked about the pre-game communications. So this is where you're able to chat with the different gamers that are joining the lobby and they're wanting to play. This is where we handle also the latencies as well. So inside our platform, we detect all the different latency from the different gamers that are in the lobby, so that you can actually make a decision in our demo of where you would like the server side to actually be hosted. So it can either be hosted actually on the device itself, which comes in, which I'll come back to later in this video. There are some advantages for that, or it could be hosted actually on our computer and orchestrated there itself. What we actually do is we detect the latencies and then we put those within the lobby system chat. You can't see it as part of the chat, but we actually use those streams to actually communicate that latency between the different gaming devices and the server side to determine where the best place will be for the game session to be hosted. Then we have the netcode transport itself. Now, of course, on this slide, I'm just showing one instance of the actual Unity engine. There will be multiple clients depending on how many gamers are actually playing. So we have an outstream and an instream. Okay, so we're providing the capacity to deliver the game data itself back to the server, whilst then also communicating the state of all the other gamers back to everybody else. Okay, so this is all happening across our streams. We then have the liveops dashboard part of this, and this also you could actually take this from the netcode directly. In this particular example, we've tapped it off separately so that we have a global view of all the in-game traffic and data, and what we're doing is using a stream to capture that from every server, and then we put it through a number of stream workers to actually then process it and prepare it for display via API to the liveops dashboard. Let's talk a little bit about the architecture a little bit more and how it can be implemented in real world scenarios as well. So what I've done here is I've created a very simple view of how this would look. So I've only put three of Macrometa's points of presence for this diagram. But imagine you've got all your gamers who are connected to GDN, to Macrometa GDN, and they're going to start playing a game. And we've gone through that lobby system, like I was showing you earlier, where we've communicated all of the different latencies that are going on. Okay. Now, obviously, if you see over here, the one on the far right has a super low latency of 5 milliseconds. Therefore, in this case, they would actually end up they could be made to host the server side of the client. So everybody has a client, the one with the lowest latency gets selected to actually hold the server side as well. But that might be great if you're running something over, say, a local network, or over a mobile network where the gamers are all very tightly packed together in a specific location. It may make a lot of sense for an actual device itself to actually have the server. However, if that person quits, then obviously you've got a problem of preserving the state, because it's in the device itself that has gone, and the game is basically over. So what we would actually do is, like we do in this case, is we actually start the actual server side actually at the edge itself, actually on our compute. Now, if you were to take this a step further, like we've done with some of our telco partners, you can actually implement multiplayer gaming where on the telco cloud, or what people call the MEC, the multi-access edge compute. So with this in mind, for example, in a 5G context, you could actually then program the network with the appropriate network slice that you require to actually run this game. So, for example, it could be a high bandwidth game, so you might select enhanced mobile broadband, or you might be looking for something where you want ultra reliable, low latency connectivity because of the nature of the multiplayer traffic itself, where you actually want to provide the best possible latencies for the actual game traffic. You could implement voice traffic as well, obviously, of course, over the telco network, so you get an outstanding in-game comms. But what we really want to demonstrate is here how you can use the network exposure function and the network slice selection function to actually further enhance the way that you build your games using Macrometa and a programmable network. Okay, so finally, thank you for staying with me during this video. What we've done today is we've talked very much about how to delight and engage with your gaming community. So we've also demonstrated how you can gain insight into that journey and that experience by using Macrometa GDN to actually manage all your netcode transport, all the in-game data, and keep track of it and analyze it and provide real-time insights, not just to play the game, but also on top of that game for your liveops dashboard, or perhaps even if you were running an esports event where you're providing commentary, you can do all those cool things. We've shown that with Macrometa GDN you have global scale to deploy your applications and manage all this complex data, and we've shown you how you can use that data to gain insights into the actual what's going on in the game itself. Have a look at Macrometa GDN. We have a public playground where you can actually come and try it out and try and build some games and have some fun. So as we say, play, learn, and develop. And we have a number of gaming customers that are using Macrometa GDN for things like the metaverse, so that we have some people developing metaverse applications on Macrometa at the moment. We also have XR type applications where people are looking to do their real-time rendering based with computer vision for XR applications, which is super cool. And we also have partners who are building ping acceleration technology for esports games. We have cloud gaming being deployed on here. Yeah, the list goes on. Anyway, it's a really great platform. I'm really excited to see what you guys do with it. So if you have any questions, please reach out, let me know, and I'll happily talk about gaming and what your use case is and show you how Macrometa can add value. Okay, thanks for listening. Take care.